Okay, so let's look at another form of first order differential equation. For this one, the third one, we're looking at the method of solution of first order homogeneous ordinary differential equation. Now, I said something, I said a differential equation of the form. Now, the form of this is that dy dx is equal to h into y over x. So you have this. So a differential equation of this form is a first order homogeneous equation. That is, the sum of the parts of x and y in each term are equal. Now, how do you solve a differential equation of this form? The task is this. To solve a differential equation of this kind, your first task is to take y. Let y be equal to v of x. You have this. Now, if we are to find dy dx, let me take your mind back to differentiation. Recall that in differentiation, if I have that y equal to uv, for this case here, obviously I would use product rule, right? Why? They are multiplying. So we said when you're differentiating terms such that these two are multiplying, you'd have to use product rule. Now that's one. U is in terms of x. Also, v is in terms of x. For the product rule formula, we have that dy dx is equal to v du dx plus u dv dx. Let me explain this thing better. All right, this is just basic concept. The proper explanation is this: you keep the first one, or this, let's call this 1 and 2. You keep the second one constant. Differentiate the first one with respect to x, plus keep the first one constant. Differentiate the second one with respect to x. Now bring it here. From here, we'll have that dy dx is equal to, keep this one constant, that's this. Differentiate this with respect to x gives you dv dx. So you have this. Of course, plus, next up, keep this constant, v. Differentiate this with respect to x gives you dx all over dx. All right? When you have v with respect to x, you have dv dx. When you have x with respect to x, you have dx dx. So we have this. From here, you have that dy dx, it's equal to x. You have dv dx plus, this gives you what there? V. Obviously, the x cancels out. You have what there? 1. Right. Now, moving on, I have that dy dx is equal to, you have x dv dx plus v. Right. So in most tasks, you see this. This is how they got the answer. Right. When they will say put dy dx as this, know how they got it. But in order of arrangement, usually they put v first before this. It's more like saying that dy dx, so dy dx is equal to v plus x dv dx. Just understand how they got this. So most people will tell you that put dy dx as v plus x dv dx. How? I've just showed you how they got it. Right? Product rule differentiation. Moving on, we said to solve differential equations of this form, the task is simple. You want to put y, so you just make two substitutions. The first substitution is that put y as vx. The second substitution is that put dy dx as v plus x dv dx. When you put these two, it will change the equation from y and x to v and x. Now, when it does that, your own task now is to collect like terms and then solve it using what there? Variable separable method. That's the task there. Right? All right, let's take some questions under this. Please. Let's take some questions under this. I have about 12 questions here. So some of the questions, they don't have answers. Number one. All right, let's see some questions, please. Let's take some questions on this. Number one, dy dx equal to x squared plus y squared all over xy. Number two, dy dx equal to x minus y all over x plus y. Number three, dy dx it's equal to x plus y over x. Number four, dy dx equal to y squared minus x squared all over 2xy. Number five, you have dy dx equal to 2xy plus y squared all over x squared. Give me a sec, please. Next, we have dy dx being equal to y plus 2x all over y minus x. Number seven, dy dx equal to x squared minus y squared all over 2xy. Number eight, dy dx equal to 3y minus 2x all over y plus x. Then finally, number nine, dy dx equal to y squared plus 3xy all over x squared. All right, I think we're good to go. All right, so let's take an example on that. Let's look at this question here. The first thing you want to observe is this. I've always said, if you're going for an exam, of course, imagine yourself in the exam space there. One of the things you want to observe is the fact that in exam they won't tell you using put y hint, put y equal to vx. They won't tell you that's an exam. They won't give you a hint. If you look at the last one we did, it was called variable separable. And the major difference between variable separable and direct integration was the fact that in variable separable we had what there? X and y terms. While in direct integration it was just x terms. Now, does it mean that any differential equation I'm given that has x and y would be variable separable? No. In some cases too, it will have x and y, but variable separable will still not work. It wouldn't. The question will now be, how do I identify it? Because your exam is being timed. You don't have all the time to start testing everything. No. You should be able to look at it and then know what to do. If I'm given this stuff here, I know it's not going to be direct integration. There's y here. So it has to be what there? Variable separable, perhaps. Now, how do you know it's not variable separable? Very simple. The concept or the idea behind variable separable is that you want to separate the variables. Take all the x terms as well as the x to the right hand side of the equation. take all the y terms as well as the y toward the left hand side of the equation. I can bet you if I say take all the y terms as well as y to the left hand side, you cannot. Try it. Try to see if you can move everything with y to the left hand side and leave only x terms and the x on the right. Try it. Let's see. Try it and see. See if it's possible, if you can arrange the variable. See if you can move y squared. Just see if you can move anything that involves y here to the left hand side with the y, and if you can move all the terms with x and the x to the right hand side. Try it and see if you can. Just see if you can do mathematics, not mathmagic. Right? Do mathematics, not mathmagic. Now see if you can do that. Then so it's not work. That's how you know it's what there, not variable separable. That's it. Because in the exam they will not tell you use this. They will not give you any hint. Just say solve it. And there are like 5 different methods. How do I know the one to use? You have to be very smart. You have to be very fast. Right? X and Y. The first that comes to my mind is what there? Variable separable. I will now rush the rough section to go and see, can I separate variables? If yes, work with variable separable. If no, in this one you can't separate it. So if you can't, what do you do now? Now start looking at what there. Let's see if you can use what there. Y equal to what there? V of x. Or perhaps integrating factor. Or perhaps exact equation. At this point here, obviously, let's work with the integrating factor concept. What's the first thing you do here? The first thing you do here is say, let y equal to v of x. Obviously, because I cannot move y and dy to the left hand side and x and the x to the right hand side. So let y equal to what there? V of x. We've done this before now. What we say, if you use product rule, dy dx equal to v plus x dv dx. All right. At this point, your next task is to do what there? Substitute. So you now say substituting. In my substitution, I would have this. In my substitution, I'll have this. So this man here, this one here, dy dx becomes v plus x dv dx, that's dy dx, is equal to this one here. Wherever I see y, put vx. So it becomes x squared. So I have x squared plus, you have y squared. We said y is vx. So in place of y, I'll put vx. Now y is being squared. So square this all over x. So I have x. In place of y, I will be putting vx. So I have this. All right, so I have this. So I said when you substitute y as this and dy dx as this, the major change you observe is that the equation will be transformed from being an equation in terms of x and y. It now changes to an equation in terms of what there? X and v. No longer y, now v. So you have this. What next? Simplify this, factorize. Let's simplify. In simplifying this, I have that v plus x dv dx, it's equal to, this gives you x squared plus, expand this, what do you have here? V squared, x squared, all over this and this, x squared v. So you have this. Okay, what next? Always observe that usually these things will factorize. I can see x squared, x squared. Let me factorize it. So I'm having v plus x dv dx. It's equal to, bring out x squared here. What do you have here? Of course, x squared divided by x squared gives you what there? 1 plus x squared here. We cancel x squared. You're left with what there? V squared all over. Factorize x squared here. I have x squared. Then you have what there? V. Of course, x squared times v gives you x squared v. At this point, this would cancel this. This is the usual pattern here. Right? After factorizing, you observe that something will cancel out. Expect it. About 95% of the times, they would factorize and cancel. So it's something to look forward to. All right? Okay. Moving on. I now have that v plus x dv dx It's equal to, what I have here is now 1 plus v squared all over v. The next thing I want to do is move v from here over here. So I'll be left with x dv dx. It's equal to all of this 1 plus v squared all over v, plus v comes here becomes minus v. So I have this. Okay, next up, let's solve this. So this gives you x dv dx. It's equal to, of course, this is all over 1. The LCM here of v and 1 obviously is v. So v divided by v gives you 1. 1 times all of numerator gives you the same thing there. Because 1 times anything is that thing. So it gives you everything here. That becomes 1 plus v squared minus v divided by 1 gives you v. V times v gives you what there? V squared. So I have this. All right, so we're here. At this point now, observe that v squared minus v squared. So this will cancel this out. I'm having x dv dx. It's equal to, I'm left with 1. So 1 all over v. All right, so how do we solve this? What do we do next? Let's move the v here and x here. Let me just give you a simple pattern about it. This is level 200, of course, so I won't start shouting plenty. What to do here is simple. Whenever you're having this case, what to do is that dx goes up and this v becomes a denominator. Please. All right. This dx here goes up. This x comes down as a denominator. And here's your reason. You're having x dv all over dx is equal to 1 over v. Please listen. This and this are the same thing. You can take this one here to numerator like this. It's still correct. If you want to do cross multiply, this and this, this and this. So this and this I have x dv is equal to dx times 1 is dx. Now to get this man, sorry, xv please. X times v dv please. So x v dv, yeah. So to eliminate x here, divided by x, divided by x. This will cancel this. So you have v dv, right? You have v dv is equal to dx over x. Please always note this stuff. With time, I will start skipping it. You know what to do. If I have x here and dv, the concept is now is that dv goes up as numerator and x comes downward. So with time, I'll be skipping this whole thing. You should know how I got this. All right? Taking this man off. All right, so at this point here, I want to integrate both sides. Integrating. See, I'm solving this thing. This is how you solve an exam, step by step. Right? How you solve an exam, step by step. You have that the integral of v dv is equal to, this becomes the integral of this one here, dx over x. This now becomes the integral of v dv is equal to, the task here is to shift out the x. If I shift out the x here, here will be what there? 1. So I now have this as integral of 1 all over x dx. At this point, we can proceed to integrate. If I integrate v, what do I get there? V squared all over what there? 2. Obviously, here I'll have to use general method. Add 1 to the power. Becomes this. This is 1. Add 1 here. That becomes 1 plus 1. That's 2. V squared all over. Divide by the same thing. This is equal to, if I integrate 1 over x, what do I get there? Ln x. So it becomes ln x, then plus what there? C, your constant. All right. What next here? We can multiply everything by 2. I want to get the value of v first. Multiply by 2. So 2 times this will cancel out. So 2 cancels this. I'm left with v squared. Or simply say, bring 2 here. We have that v squared is equal to 2 into all of this. Let me just write it step by step anyways. This, all right? So v squared is equal to 2 times ln x gives you 2 ln x plus 2 times c is 2c. You have this. We don't want to get v. Initial variables were in x and y. So when you're at this point, your next task is to recall what v and x means, right? But recall that the relationship between v and y is that y is equal to vx. From here, what's your v? I'll have to divide here by x, divide here by x. This cancels this. So v will give you what there? Y over x. After solving, you have to resubstitute the value of v as y over x. If I do that, would have that this point here, v squared becomes y over x. So v squared becomes y over x squared. V squared, it's equal to 2 ln x plus 2c. I have this. Now expand this. I have y squared all over x squared. It's equal to 2 ln x plus 2c. Most authors do not, or most authors, or most guys would say 2 times c is c. And the reason is because what you're doing here, understand something. If you look at most text, most authors, and most other persons online, they'll tell you that 2 times, if you do this, you'll see the answer as 2 ln x plus c. You won't see 2c. Now, why is this so? The reason is simple. Now, here's their own assumption. They are saying that c is a constant or perhaps a number. Now, if I say 2c, let's assume that c is equal to 8. All right, but the full concept about c is that c is a number, a constant. Now, if c is 8, if I do 2c, 2c becomes 2 times 8. And that gives you what there? 16. This is still a number. And so far as that number is not attached to a variable, whether x or y, it should be what there? C. So for some persons, they'll now say this is equal to 2 ln x plus c. But in this case now, the c now is now what there? 16. But c is c, literally, any number. So you just have to know that concept. That's about it. I just felt like telling you why too. All right, let's move on. Let's move on, please. From here, look up, please. This is all over 1. Of course, 1 times y squared gives you y squared equal to this, and it gives you x squared, this into this, into 2 ln x plus 2c. Okay? Multiply this, and what do you have here? Y squared, it's equal to this and this, 2 and x squared. 2x squared ln x plus 2 times x squared times c, 2x squared c. Right? 2x squared c. In doing this stuff here, we don't want to find the value of y squared. What we want is the value of what there? Y. So what do? Take square root. Taking square root here would have that y is equal to the square root of all of these stuff here. 2x squared ln of x plus 2x squared c. So some persons, now what you have here is just what there? x squared c. You have it too. But they say that 2c is equal to what there? C is a constant. Okay. All right, so look up, please. This is not a final answer, please. If you look at this, there's x squared, right? So you can see factorize. Yes. So you can have that y is equal to roots. So watch this. I have x squared. I can factorize x squared. Well, I still have 2, but you cannot take the square root of 2, or square root of 2 just gives you root 2, which is not what I want to do. So I'll just take x squared, because I know that I can take the square root of x squared to give you x. So I'll pull out x squared like this. I'm left with 2 ln x plus this and this, 2c. Now we know that from the concept of indices, that root, or concept of SOD, from SOD, Root AB is equal to what there? Root A times root B. So if two things are in a square root and they are multiplying, we could separate them. In essence, y can be equal to root this, root x squared times root this. That's root this one here, 2 ln x plus 2c. From here, this would cancel this. So you have that y is equal to x roots. So x times, that's x root 2 ln x plus 2c. Well, if you want, you can say 2, bring out the square root. It becomes root 2x, yeah? Root 2x, but don't worry, let's leave it this way. So this is our final simplification. That's how you solve this. All right? Moving on, please.
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.